So guys, let's finish strong, right? Almost done. Number 6, number 7, and that's it. So let's look at this one, guys. It says the diagram below, not drawn to scale, shows an open cylindrical container made of metal with a circular base and a uniform thickness throughout. The length of the container from the top to the bottom is 120 centimeters, and the inner and outer radii are 14 centimeters and 15 centimeters respectively. Draw a cross-sectional view of the container showing the measurements of the inner and outer radii. Well, I would draw it like this. Sorry, I draw it like this. Yeah, and I would say the radii here is equal to, what did I say again? 14 and 15, right? 14 and 15 centimeters. So the one here is 7 centimeters, and then the other radii right here is 7.5 centimeters. That's what I would draw. So just think of it like a thermos, guys, you know? Yeah, you need to think of it as almost like a thermos. Okay, so the inner radii is 14. Okay, cool. So sorry about that, guys. I thought it was the diameter. Let me change it. Oops, sorry. So yes, so they said that the inner one is 14. So the inner one will be 14 centimeters. And then the outer one, which is from here to here, would be 15 centimeters. So guys, just think of it as like a thermos, you know, like a thermos that you drink from. Think of it as something like that, guys. And usually a thermos has like a thin film in it, right? For you to keep stuff warm. So think of it that way. And I would definitely draw it just like this. I would show that my radius, maybe I'd make it different colors or something. Maybe I should make this one a different color. So the longer one is 15 centimeters here, and the short one is, let me make it red. The short one is 14. And yeah, that would be it. That would definitely be it for my 2 marks. Yeah, that would be my 2 marks. I'd be done. And then the next part now says, show that the capacity of the container is this, right? So this makes perfect sense now. To find the volume of any container, guys, the volume is equal to pi r squared h. Cool. So we need to find the volume. So what I would do is I would find the volume for the big one. So I would say pi r squared 15 squared. Pi times 15 squared times the height is 120. Remember I said that the height of the container is 120 centimeters anyway. So 120. So that would be the outer part. I'd find that this would end up being V is equal to 22/7 times 15 squared is 225 times 120. Is it 225? Yeah, I think so. Yeah, and I'd find my volume. Let me find my volume. Let's work it out, guys. We're doing it together. We're working these out, guys. So 22 times 225. Oops. 22 times 225 times 120 divided by 7. All right, so that's my volume for the outer circle. That's my volume for the outside. So this is 84857.142. Cool. Then I'm going to find the volume for the inside, which is pi times 14 squared times 120. And this would be equal to 22/7 times 14 squared times 120. I'm not sure what 14 squared is though, so let me work that out. So 14 times 14 would give me 14 squared.
196.
14 times 14 is 196. And then I'd multiply that by 22. And then I'd multiply it by 120. And then I'd divide this by 7. And this would give me 73, volume is equal to 73920. Cool. Am I doing it right? Am I doing it right? Am I doing it right? Let me think about it. Oh, holy crap. I didn't think of that though. I didn't think of that at all. Does that make any sense though? That doesn't really make any sense to me. 120, 120. That's the outer circle. So the inner is 1 centimeter in. Oh, I get it, guys. All right, guys. So guys, basically this shouldn't be 120. This is actually gonna be 119. I think this was kind of hard though, to be honest. 119. And the reason why it's 119, guys, is because of the space. This space here is just 1 centimeter. So it would actually make the inside of the thermos shorter, 1 centimeter shorter. So this wouldn't be 73,920. This would actually be 73,304. So this is the answer for this one over here. So the answer for the inside of the thermos is 73,304. That's the answer. And the answer for the outside of the thermos, determine the volume of the material used to make the container. That would be this. So I actually did the second question, the second part, part C. I did it earlier. So part C is actually this, 84,857.142. That's the volume of the outside. This is the volume of the outside for sure. But the volume of the inside, guys, we'll have to subtract a 1 from this 120 and multiply it by 14 squared, and that would give us the answer, this answer here. So this wasn't too easy still. I'm not gonna lie. Trey, how you felt about this one? How you feel? Tajan,
yes,
how was this one to you as well?
Sir, that the volume, it's that the answer on the sorry, the answer on the left is the volume of the material. Wouldn't the material just be the outer circle?
Yeah, it definitely is the outer circle, which is why it's the 15 squared times the 120 times the 22/7. But for the inner circle, it's 14 squared pi, and it's 119 for the inner because of the 1 centimeter difference.
Sir, but it's asking for the material. So wouldn't that just be like, why would it be the 15? Isn't the 15 like all of that?
No, it represents the outside. So for the 15, it represents what's on the outside of the circle. So let me scroll up a bit. It would represent here. For the 15, it would represent here, right on the outside or the edge of it, for sure. So it's basically the outside of the thermos. This one was kind of challenging, to be honest.
I'm confused because you drew the line from the center of the thing to the very end.
I did, yeah, but that's what you want. That's what you want. You want it. That it says the material, so determine the volume of the material. It would be the material of the outside for sure. It would have to be what's on the outside. Like it matches exactly the outside. Does that make sense? Does it make sense to me?
Kind of.
Yeah, it's the capacity of the outside, not the inside. So that's part C, guys. Part C down here says determine the volume of the material used. That would be the outer side, the outer part, which is here. Cool. That would be the outer part. For sure. Yeah, so that's it, guys. That one was kind of difficult still. All right, so this one says here, given that the density of the material used to make the container is 2.2 grams per centimeters cubed, determine the mass over the volume. This is a ridiculous question. I'm not gonna lie, this question hard, man. I don't think this was very easy to understand. I really don't think so at all. Yeah, this is a hard one still. Straight up, this one is a hard question. It's a hard question. Yeah, this is such a difficult question, guys. So guys, what they're actually asking you for here, guys, it's so strange, isn't it? They want to actually ask you for the density, they say is 2.2. It's actually equal to the mass over the volume. But the volume here, guys, is the actual volume for the container, which is 84857.14 minus 73304. And if you subtract those two, your volume for the container itself would actually be 11,553. So this one is just weird. I'm being honest, this is really hard now. I would just be like, wow, you know, why so much for this question? This was too much. They OD'd this one, to be honest. I think they really overdid it. Mark you, if I was a physics student, I'd get it, but for a math student, this is really unreasonable. It's an unreasonable question. So it's actually 2.2 over 11553, and then the mass would be equal to 11553 times 2.2. That would give us the answer for the mass. They're actually asking us to find the mass here. And the mass would definitely be 25,416.6. And this is definitely in grams, right? Grams for sure. So if we wanted this in kilograms, this would be 25.4166 kilograms. But guys, as I said, this one was really rough still. This is one of those questions where it's better to just do everything else, to be honest. I think everything but this part. I think this part was okay, and this part was okay too. The first part was okay. This was the easiest part, the 2 marks here. This part, kind of rough, to be honest. This part to me was easier because you can tell it's the outside, but this part, this is rough, not easy. Not easy. We need to do more questions like number 6. And we've done number 6 questions before, but never seen one this hard, to be honest.